Assalamu alaikum students, welcome to the online session. We have started unit 10, that is simple harmonic motion and waves. I have introduced it in a previous lecture. Today we will discuss simple harmonic motion of different system. And that system is the motion of mass attached to a spring. In this lecture, we will discuss the motion of mass attached to a spring on a horizontal frictionless surface. So, simple harmonic motion occurs when net force is directly proportional to the displacement from the mean position, and it is always directed towards its mean position. Many body oscillates, many body vibrates, but if a single point enter in that motion, then we call it simple harmonic motion. What is that point? That point is the mean position. The body always vibrate about its mean point. Then we call that motion a simple harmonic motion. Now what does this definition means? It means force is directly proportional to the displacement. Greater the force, greater will be the distance covered by the body. And this is the Hooke's law. The greater the force is directly proportional to the displacement. Greater the force, the greater will be the body cover. The distance, greater will be the displacement. Let's come toward the motion of mass attached to a spring. We are taking a spring and I have attached it to a table. It's one end to the table and the other end from the mass. Now it's in mean position. Initially mass is at rest in a mean position. And you know, when the body is at rest, the resultant force is 0. So the resultant force on the mass will be 0. Now apply the definition of simple harmonic motion. What is that? Force is directly proportional to displacement. As we have already read that force is directly proportional to the displacement, and these all things will be around mean position. As you can see in the figure, initially the mass was at rest and the resultant force was 0. F is equals to 0. No force is applied on the mass or the spring. Now in the figure B, we have stretched the mass or the spring from mean position. Now its position is changed and its new position is the position A. Its length is increased and the body covers some displacement because we apply a force on the spring. Now its new position is position A. Now see, we have applied force on the spring and the force has stored in the spring. Force has stored in the spring because of stretching the mass from the mean position. But when we release this mass, due to the restoring force, the mass will move about the mean position. It will move towards the mean position. It will move toward the mean position due to the force, and that force is basically a restoring force. And when mass move toward the position O, its speed will increase, and when it move away from the position O or the position mean position, its speed will be decrease. When it move towards the position O in the figure C or in the figure B, its speed will be increase or maximum. When it will move away from the position O or mean position, its speed or its velocity will be decrease, or it will be opposite to the force. When speed will increase, its force will decrease. As you can see in the figure, the force toward the mean position will decrease. Now see on the right hand side of the board, this is the Hooke's law, that is force is directly proportional to the displacement. F is directly proportional to x. F is the force, x is the displacement, and k is the spring constant. K is the spring constant. We can say that spring constant or the strength of the spring, how strong is the spring or how thick or thin is the spring. According to Newton's second law of motion, F is equals to ma. Force, when force will increase, the body will accelerate more, the greater the acceleration is. If we want to find the time period of simple harmonic motion of the bodies that executing a simple harmonic motion, then we can find through this formula. T is equals to 2 pi under root m by k. K is the spring constant value and m is the mass, pi is constant and 2 is also constant. By putting all values on this formula, you can easily find out the time period of simple harmonic motion, time period of the bodies executing simple harmonic motion. So this was the lecture of simple harmonic motion of a mass attached to a spring. Hope you understand. If you have any query, you can ask the comment section. Take care. Allah Hafiz.